In this video, we're going to divide polynomials, and we're going to focus this video on just long division. A polynomial divided by another polynomial can be done using long division. But before we get into that, what I want to do is show you long division of regular numbers that don't have x's in them, that aren't polynomials, and remind you how we did it and what all the steps broke down into when we did it with numbers when we first learned long division. Some of you may not have done long division in a while because you've had your calculator for so long. So we're going to review this, not so much because I need you to do long division with numbers, but I need you to think through the steps that are involved in long division of numbers, because those same steps are going to transfer over to polynomials. So we've got to think through. So don't skip over this part of the video, because you really need to understand each step and what its purpose was when we did them with numbers. Whenever I used to do long division before I had the calculator, what I would do is I would divide 62 into 534. I don't want to divide it into the whole 53,421 all at once, because I have no idea what the answer would be. But I can focus on the 62 into 534 because I know it will fit inside of there. And you're going to put the answer right here above the last part of the 534. And those little things of formatting are going to be important when we get to polynomials. So the trick that I would always use, and you may have another trick, but I would always take the front number into the first thing it'll fit into. So just to get a guesstimate of how many times 62 goes into 534, what I do is I say, how many times does 6 go into 53? It's just a little shortcut kind of estimating thing. And so 6 goes into 53 8 times, and that's all it will fit. And so I'm going to start with an 8 up here, even though that may be too much. That's always a good starting point, so you're not just randomly picking numbers to start with. So I'm going to try 8, and I'm going to come over to the side and do 8 times 62 and see what we get. And we get 496. As long as 496 is smaller than the 534, then we know that's the right answer. So now we subtract. Notice we drew a line and we drew a negative sign, or a minus sign, and that's going to be important in polynomials as well. After we subtracted, then we can't fit 62 into 38, and so we bring down the next number and start over our process. So the 4 steps in division are divide, then we multiplied, then we subtracted, and then we brought down the next number. Those steps are going to be repeated over and over again with numbers and polynomials. So we need to start over again. We just brought down, and now we divide 62 into 382, but again the shortcut is just kind of focus on the front numbers and how many times does 6 go into 38. It will fit 6 times. So use that as your first guess and see if it actually works. Sometimes it'll be too much, but we'll find out. And we get 372, so it does fit inside of there, and so it's not too much. So we're going to subtract and bring down. Then once again, I divide 62 into the 101, and to guess, I say how many times does 6 go into 10, just to give me an idea, and that only will fit once, so it's likely that 62 would only fit once, and 1 times 62 is just 62. Then we'll subtract that, and 39 is our remainder. The reason we know it's the remainder is because there's not anything left at the top to pull down. We're kind of at the end of our problem right here, and so we know we're done. So it's important to keep things lined up. Keep in mind what we would do with that remainder. There's several ways you could leave the remainder or keep going in the problem. When you first learned to long divide, they would say write remainder 39 after your answer of 861, something like that. And then later we figured out that once we learned fractions, that 39 could be put over the divisor of 62. And so that is a fractional remainder, 39 over 62. So it's a mixed number, 861 and 39 62s. And keep in mind also, this is just a little thing, that what is understood to be happening between the number and the fraction is kind of a plus sign. We never wrote the plus sign when we did mixed numbers, but it is adding that remainder to the answer, not multiplying it, because that's going to be important when we get to polynomials as well. And then later, when you learn decimals, you ended up putting a decimal point here, adding some zeros, and you would keep going and bringing down zeros, but we're not going to do that step here. We're going to leave the fraction answer. So dividing a polynomial using long division will be very similar in steps to the previous problem. So what we've got going on is we have a binomial that's getting divided into a polynomial, which has many terms, but we're going to focus on two terms into two terms and just focus on the front. And even more than that, we're going to focus on the first term into the first term. And it's easier not to think of it as division, but to go backwards and kind of fill in the blank. Remember, the blank is going to go right above the end of the thing you're dividing into. And so we're going to fill in this blank by thinking, what could I write in that blank so that when I multiply it by 2x, I get 2x to the fourth. And what you need is 3 more x's. And so we're going to come off to the side and do this multiplication. And you have to do it by the whole 2x minus 1, even though we were focusing for a second on the front numbers. And when you multiply x to the third times 2x minus 1, you distribute it, and you get 2x to the fourth minus x to the third. That is what you're going to write underneath here, is 2x to the fourth minus x to the third. So the next step in the process was subtracting. But subtracting is the same as adding the opposite, as we've seen before. And so rather than writing a subtraction sign, the subtraction will apply to everything. So you're going to add the opposite, and what I call this is draw the line, change the signs. I have the little saying down at the bottom here, draw the line, change the sign. So as soon as you draw that subtraction line that you're going to put underneath there, instead of writing subtraction, think of it as adding the opposite of everything that follows across the bottom. So adding the opposite is the exact same thing as subtracting, and that's the way we're going to focus on these, because it needs to be distributed to both terms. So now we add down, and these cancel, and these, it's kind of like a 1x to the third. So 3x to the third plus 1x to the third makes 4x to the third. Then our next step is bring down the next term. If you do not get these front two to cancel out, you chose the wrong thing up at the top. So you always want the front ones of the two terms to cancel out, and if it doesn't make a 0, then you did something wrong. So keep that in mind. Now you start the process over. We're going to divide this into this, but we focus on the front numbers, and we say, what do I write up here at the top so that when I multiply it by 2x, I get 4x to the third? Well, we need a 2 times the 2 to give us a 4, but we also need 2 more x's to give us the x3 that we need. So we're going to come off to the side and do 2x squared times 2x minus 1, just to see what we get, and that's 4x to the third minus 2x. So we write that underneath. I'm sorry, that's a x squared. So this would be an x squared as well. So then you draw the line, change the signs. Think of it as adding down now, because adding the opposite, which we've already changed them to the opposite. This should cancel. If that does not cancel, we did something wrong. The next one will just add down and give us negative 2x to the second. Then we bring down the x, and then we start the process over, saying what do I write up here at the top, so that when I multiply it by this 2x, I get this negative 2x squared. So what I need here is a negative 1x, and the 1 is optional. You could leave off the 1, but you can't leave off the negative, because negative 1x times 2x would give us negative 2x squared. Now, I didn't write a sign between the first two, but I need to. I need to write a plus there. If it's positive, write a plus. If the number you need to put in there is negative, write a minus. And then we do negative 1x times 2x minus 1, and that's negative 2x squared plus x. So that's what I write underneath. And then I draw the line, change the signs, and then add down. This cancels, and this makes a remainder of 0. Now, there's still another guy to bring down, so I'm going to call that a 0x, just because it's in line with the other x's, and then I'm going to say plus 1. And then after we bring down the 1, we say, what could we multiply by 2x to get 0x? And I'm just going to write 0 up here, just to have everything line up all the way till the end. And then 0 times all that is just 0 times 2x is 0x. 0 times negative 1 is 0. And then you could draw the line and change the signs. Not that zeros can actually become negative, but this cancels out, and then you have 1 plus or minus 0. Either way, you're going to have a remainder of 1. And so the way you write this is you add the remainder of 1 over 2x minus 1, and that's how you write the answer, except we can get rid of the plus 1 now and just leave it as x to the third plus 2x squared minus x plus this fraction. And that's our quotient, that's our final answer. The last thing I want you to notice is how lining everything up was really, really important. We cannot add these two things together or subtract them or anything unless they're like terms, and so they both had to be x to the fourths. Notice all the way from the top to the bottom, we have all our x to the 3 power lined up, x cubed, and then in the next row we have all our x squareds lined up. We have our x to the first power all lined up. It's part of the reason why I put an x on those zeros down at the bottom, just so they would all be x terms, even though you could drop off the x eventually. And then even from our 0 down to our 1, from top to bottom, we had all constants or integers in those spots, which means there was no x on those. And then our remainder is out here, and remember it's always the remainder over the divisor, and you write a little plus sign in between them.